you notice with the sigma that we did, it's very easy because you had very small amounts to add up. But what if you got 100 or 1,000 terms and you want to add up? So let's have a look. We need the formulas for Sn. Now, I'm going to go through these quickly, summing the terms of an arithmetic and geometric. Okay, what you remember from your textbooks and your notes that the arithmetic series, this is the formula, this one, Sn is n over 2, etc. there, or you get a last term where L is the last term. The geometric series, you've got two possible ones that you can use. This one is used if r is bigger than 1, this if r is less than 1. By the way, of course, you can pick one and just use it. So if you use a rn minus 1 over r minus 1, that is fine too. But also for convenience sake, we look at this. Now here's something that you might not know. We've got the last term for the arithmetics. Here is the formula for the last term of a geometric. Not in the formula sheet, but maybe well worth knowing. But again, not necessary, but I'll just put it in for fun. Okay, so we look at the next example. Example 11. Now, they're going to give you here a series, and they're asking you to add up the series, the first 100 terms. Now, what is the series? Well, clearly arithmetic, because we've got a first term is 3. Okay, now what do we add on here? Well, what's 7.5 minus 3? The constant difference is 4.5. Remember, they did not tell you that this thing is arithmetic. Okay, you had to find that out. Be careful, it's not geometric, it's arithmetic. So now we keep adding 4.5. Check what's 12 minus 7.5 is, of course, 4.5. Okay, now great. Now we've got n is equal to 100. There's 100 terms that we want to add up. Okay, so what's the formula I'm going to use? Sn is n over 2, 2a plus n minus 1d. And we've got the sum of the first 100 terms is 100 over 2 into 2 multiplied by a plus 100 minus 1, and the constant difference is 4.5. Now, I'm going to use technology here. I'm going to work this out using technology. But if you didn't have a calculator, that's 50. That comes to 6. That's 99 multiplied by 9 over 2. Okay, so what does this come to? Well, that's easy now. You can simply use a calculator. You can even go from this step, and you get 22575. No problem. Simple calculator work. Okay, remember, you've got an infinite series, a series that goes on, and it's arithmetic, and you're working out the sum. You're adding up the sum of the first 100 terms. Okay, nothing in that one. Okay, but now, look at the next question. Now be careful of this example, because this time we have a finite series. It means it stops. Have a look here. It actually stops at 228. Now, we don't know how many terms there are. We know it's arithmetic. Now have a look at this. We've got a term with an unknown position. It's 228. Now the first term is 3, d is 4.5. We don't know the position, because listen, you want to know how many terms you've got to add. If they said sum the first 100 terms, that's easy, but they give you a term in the series, and the problem is we don't know what its value, its term value is. What is its position? So very simply, watch this. If we go and look at this, what do we know? We've got the formula for Tn. Tn is a plus n minus 1d. Okay, we know that 228 is the term with the unknown position. The first term is 3 plus n minus 1. D is actually 4.5, which is the same as 9 over 2. Okay, now if I bring that across and subtract, I get 2, 2, 5. Okay, now it's gone across, and then we can distribute this. It's 9n over 2 minus 9 over 2. Okay, I think the best thing to do here is to multiply everybody by 2. And if we do that, what would that be? That's going to be 450 is equal to 9n minus 9. Okay, all right, which is not a problem at all. So if you've got that, 450 is equal to 9n minus 9, we can divide. In fact, what you could do is you can divide everybody by 9 anyway. So if you divide by 9, what happens here? Okay, or you could bring that across and get 459 is equal to 9n. Now, if you look at this, what is 459 divided by 9? Okay, clearly it's going to be 51 equals n. If you verify that, let's check. What is 51 times 9? 1 9 is 9, 9 5s are 45. So you can clearly see that it works out at 51 terms. In other words, the 51st term is 228. So we now know that this term is clearly known, and we have 51 terms in the arithmetic series. Okay, so the rest now is pretty straightforward. What are we going to do? We're going to simply now use the formula. Now, very important here, we know that A is equal to 3, D is 4.5. We know the number of terms is 51, but we also have the last term as 228. Now, there is a formula that we can use if you have the last term, and that is this. This is Sn is n over 2a plus, I know that the formula sheet does it with a little l as well, but remember, it's not a 1. Be careful, some people mistake it as a 1. It's a little l for last term. I prefer the big L, but for the formula sheet, they often write a little l. Okay, so what do we know? Sum of the first 51 terms, 51 over 2. The first term is a, plus the last term is that. And if you work that out, it comes to 5890.5. Okay, now that's simply using a calculator. Now listen, you could also use the other formula for Sn, n over 2, 2a plus n minus 1d as well. But I always, with a finite series, use the last term formula. Quite cool if you think about it. Okay, shall we move on to the next example? Example 13. Find by means of a formula the sum of the first 7 terms of the series. Careful now, what do you think it is? Arithmetic or geometric? Let's test. Okay, well, I don't think, if I'm going from a quarter to an eighth to a 16th, you're not really minusing or adding anything, but what we're doing is I presume that we're going to be multiplying by something. And I think, if you look at this carefully, I say that the a is quarter and the constant ratio is a half, because what's a quarter times a half is an eighth times a half is, of course, a 16th. If you were stuck, you can check this. T2 over T1 is 1/8 divided by a quarter. If you don't have a calculator, what's that going to be? That's going to equal 1/8 multiplied by 4/1, which is a half. Okay, just be careful of that. Use your calculator to check that, but you can clearly see you multiplying by that. Okay, sum of the first 7 terms. Now, the constant ratio here is smaller than 1. So I, for convenience sake, will use this formula. Sn is a 1 minus r to the n over 1 minus r. Okay, so the sum of the first 7 terms is a quarter into 1 minus a half to the 7 divided by 1 minus a half. Okay, now people, I'm not going to really do this, on camera, but what I want you to do is to use your calculator, look at the study notes. You really would use a calculator to work this out, and it comes to 127 over 256. That's really just simply, if you use a Casio or a Sharp, what you do is you go in and it does it for you. Technologically speaking, it's wonderful. Okay, so don't stress with that. Don't try and do jiggy with this thing. Okay, leave that for Jay-Z doing trigonometry. It's much more romantic there. We don't want to waste time with this numerical stuff. Okay, cool. Example number 14. Haha. Finite, it stops. Okay, now my question to you is, how many terms are there? How many terms are we adding up? Well, we have a term with an unknown position. We need to get that. We know that the first term is a quarter, the constant ratio is a half. It's geometric. So important, this, boys and girls. You need to be aware of this. Don't make the mistake of thinking it's arithmetic. You're going to be throwing away all your marks. Okay, now, if it's geometric, what's the formula for terms? There we go. Now, we've got 1 over 1024 is equal to a quarter into r to the n minus 1. Okay, now what can we do here? Well, this, you can't multiply those two, but what I could do is I could go 1 over 1024 divided by a quarter, which really is the same as tip and times. You can verify this. It's going to be 1 over 1024 multiplied by 4/1, giving you a half to the n minus 1. Now, if you look at this, 4 goes into 1024, will go 1 over 256. Okay, now, if you have a look at this, this is quite nasty. Now, there's two ways you could approach this. And what I do like is using the idea of logs. Now, if you look at logs, what we could do, so let's have a look at two possible ways. If you use the log button, you can go log, okay, the base is a half, so it becomes the base on the other side of the fraction. 1/256 is equal to n minus 1. Look at the laws of logs. Go to the lesson on logs if you stuck the conversion from the exponential to the logarithmic form. Now, if you work that out in a calculator, you'll find that this comes to 8 is equal to n minus 1. In other words, there are 9 terms, okay, which is cool. The other way you could approach this is 256. This whole fraction would be the same as a half to the power of 8. Okay, now remember 2 to the 8 is 256. So once you've got that, you can now equate the exponents, drop the bases if you like, and n is equal to 9. Now, what I like doing is I like using the log because it does it directly for you and you don't have to faff with the exponents. So try use the logs, they're quite nice. Okay, now great. So we have the number of terms in the series. Now have a look there. There's the series, there's AR. We now know that n is equal to 9. So the question now arises is how do we find the sum of the first 9 terms? Okay, now if you have a look at this, you'll notice that your constant ratio is also less than 1. So if we look at this, we can maybe, if I bring this into view here, we can say the sum to n terms is a1 minus r to the n. I'll bring that up there so you can see better, over 1 minus r. The sum of the first 7 terms, what's the a quarter into 1 minus a half to the, and of course that n should be, 9. Okay, there we go, 9, and that's 9 there, all over 1 minus a half. Okay, and clearly that will work out is I'm going to just simply use a calculator, 511 over 1024. Definitely just use a calculator, it'll work it out for you directly. And you've got that. By the way, of course, you could have also used that other formula for the last term, but that's optional. You can stick to the one formula that, this one that I've given you here. It works like a bomb. You could have also gone the other way, r to the n minus 1, which is quite nice. I love sequences. And quite frankly, they're going to ask you some very nice questions. Is watch out for real-world applications. We're going to get there too. Okay, shall we move on? Example 15. Let's have a look. Now look at this example. We're linking to sigma here. Now sigma is quite a nasty thing because look at this. What do you notice? The r does not start at 1. So we don't have 300 terms. So how many terms do we have? This is so important. The number of terms is the top minus the bottom plus 1. And if you look at that, how many terms are there going to be? 298. Okay, very, very important, 298. Now let's expand this. Okay, start at 3 and sub into there. 3 multiplied by 3 minus 2. There's your first term. What's the second term? 3 multiplied by 4 minus 2 plus the next one, 3 times 5 minus 2. And so we go all the way down to the very last term, 3 multiplied by 300 minus 2. So what does that come to? That comes to 7 plus 10. Looks like arithmetic to me. And we're going all the way down to the very last term, 898. Most definitely arithmetic. There's a constant difference of 3. First term is 7. So a is equal to 7. The constant difference is 3. And look at this. We've got the last term as 898. So what do we know? We know that Sn is n over 2a plus the last term, or in fact, n over 2, 2a plus n minus 1d. Great. So how many terms are there? Careful now. Careful, not 300, 298, because that didn't start at 1. Okay, so what do we know? The sum of 298 terms, the first 298 terms, is 298 over 2. The first term, which is going to be 7, plus the last term, which is 898. Okay, work that out. 134,845. Pretty straightforward. So can you see how it links so nicely to sigma notation? Very, very cool. Example number 16. Okay, let's look at it in terms of the geometrics now. The geometrics. Okay, have a look there. Once again, whoa, guys, careful now. what are the number of terms? Not 5, but watch this. The number of terms is top minus bottom plus 1. There's actually 6 terms from 0 to 5. Think about it. 0, 1, 2, 3, 4, 5, 6 terms. Okay, let's expand this and see what we get. Okay, so it's 4 minus 2 to the 0 plus 4 times minus 2 to the 1 plus 4 times minus 2 squared, and that goes, in fact, this goes all the way up to, let's see, we can go all the way up to 5. 4 plus 4 times minus 2 to the 5. Now look at this, there's 1, 2, 3, 4, 5, 6 terms. Simplifying this will give you 4, because that's going to be 1 times 4 is 4. 4 times negative 2 exponent 1, not a problem. Minus 2 to the 1, minus 2 times 4, negative 8. This one is 4 minus 2 squared. 4 times 4 is 16. I think this is geometric. What is this? 4 times negative 8, which is negative 32. So we go on. And if you have a look at this, what's this going to be? That's going to be positive 64 minus 128 if you work that out. Okay, 1, 2, 3, 4, 5, 6. Now people listen. In a case like this, it's very simple to work it out. But watch out, they might just say, by using a formula. Okay, very important. Now you know, if we work this out there, what are we going to get? Well, let's see, 4 minus 8 plus 16, etc. This thing will definitely come to negative 84. But if they say use a formula, this is what we'd have to do. Well, we know it's geometric. A is equal to 4. Constant ratio, well, we're multiplying by negative 2 all the time. Off we go. You see, 4 times negative 2 minus 8. Minus 8 times minus 2 is 16. And how many terms are there? 6. So the sum of the first 6 terms is going to be what? Going to be A into, that's less than 1, so it's 1 minus r to the 6 all over 1 minus r. Work that out, negative 84. Simple calculator work. By the way, of course, if you want to use the other formula for the last term of a geometric, you can use this formula as well. Sn is a minus r times L over 1 minus r. It works quite nicely as well. So that's also acceptable. And then you would sub in, what's that? S6 is the first term minus the constant ratio times the last term, which is minus 128, divided by 1 minus r. And it will also give you negative 84. Okay, so you're happy with that? Cool. These are all the different angles of questions that can be asked in sequences and series. Good stuff. I'm loving this. I'm loving this. Okay, next example. Example 17. Man, this one. Woo-hoo-hoo. Moment of silence, boys and girls. Look at the sum, but do not run away. Okay, listen to me. Let's attack this thing. It's actually much easier than you think. It says determine n if the sum to n terms, that means the sum to n terms is equal to 155. Okay, now what on earth are we meaning by this horrible thing? Check this out. Watch this. Firstly, let's expand that. Okay, well, what do we know if we expand that? 3 times 1 minus 1 is 2 plus, okay, r is 2, 3 times 2 is 6 minus 1 gives me 5. The third term, 9 minus 1 is 8. Looks like it's arithmetic. Goes all the way, and that goes all the way to n terms. Now, if we sub in n, we're going to have to get 155 terms, the sum of 155. Now listen, what it really says to you in this example is how many terms would you add up to get 155? Look at this. If I said to you, how many terms would you add up to get 7? Well, the sum of the first 2 terms. If you add up the first 2 terms, you get 7. But now the question is, they're giving you a sum, which is 155, but how many terms sum to or add up to 155? Okay, so how are we going to approach this? Well, we know that a is equal to 2. The constant difference most certainly is 3. 5 minus 2, 8 minus 5. And we know that the sum to n terms is 155. Okay, now what are we going to do? We know it's arithmetic. We know that Sn, and we have the last term as well. That's the last term. N over 2, a plus the last term. The Sn is 155, is n over 2, the first term plus the last term. The last term is 3n minus 1. Okay, and guys, this is quite a tricky little thing, because now what do we have here? Well, let's see. 155 is equal to n over 2 into 2 plus 3n minus 1. So what's that? 155 is n over 2 into 3n plus 1. Okay, now if I multiply both sides by 2, you would then have 310. If you multiply both sides, is going to be n into 3n plus 1. And guess what we have? We've got 310 is 3n squared plus n. And we have a dreadful, horrible looking trinomial here. That's not nice. Now, of course, if you're looking at this, how the hell are we going to deal with this thing? Well, I'm going to give you the factors of this thing. I'm going to give you the factors. 3n plus 31 and n minus 10. Now that's quite a mission, because what do we have here? We've got 3n is equal to minus 31, or n equals 10. N equals negative 31 over 3. Now the important thing with this is that to go from here, this expression, to here is quite tricky. You probably will agree with me that I was quite intelligent by actually going from here to here. But the problem is we've got two values for n. Okay, now I want you to listen to me carefully. Okay, there's two things that emerge out of this thing. Okay, firstly, we want to know how many terms sum to 155. But the big problem is, what is this problem? Is that we've got a quadratic trinomial that is horrible, and we also have two values for n. Now, you probably agree with me that this is not valid, because you cannot have a negative number of terms. You have the first term, the second term, the third, but you can't have negative 6 terms, and you can definitely not have the first 1.5 terms. Okay, you can't have a fraction as well. So this is not valid. The number of terms is clearly 10. Okay, now if n is equal to 10, we then know that it says how many, the value of n, the 10 terms, the sum of the first 10 terms will be 155. Now how can we verify this? Well, check. If you work this out, what's that? 2 plus 5 plus 8. We keep adding, what's that, 3 on as we go. 8, 11, 12, 13, 14, 17, 20, 23, 26. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you go, that's 29. Okay, now add that up and you'll get yourself 155. Okay, the other thing that I want to make very clear, guys, when you're dealing with a difficult trinomial like this one, look at this one. This is a nasty animal. That's a very nasty animal. Question is, what else could you do? I was very intelligent going from there to there. What else could you have done? The quadratic formula. Okay, I'm going to just quickly show you how you can approach that using the quadratic formula briefly. If you have a look at that, what do we know? That's the a, the b. A is equal to 3, b is equal to 1, the coefficient of n, and the c is negative 310. So you would go n, like x is minus b, plus or minus the square root of b squared minus 4ac all over 2a. Now work that out and you'll find you will get your two answers that you need. Okay, now I'm not going to do that. That's pretty standard stuff. But watch out, especially with this kind of question. Quite a nasty little animal there. Okay, so be careful. So the sum of the first 10 terms, if you work that out, gives you 155. Okay, should we apply that to the geometrics and see what happens here? Let's look at the 18th example. Covering quite a bit of stuff here. Again, I'm not going to go into this, but clearly you can see that it's geometric. Okay, how many terms will add up to 33? The sum of a certain number of terms is 33. Now it's geometric, so we know that Sn is a. If you look at that, what do we know? We know that it's going to be, let's take 1 minus r to the n over 1 minus r. Sn is 33. The a is equal to 3. The ratio is, now careful here. A negative base again. 1 minus the r. Okay, what do we know? Now that's interesting. The 3 will cancel with that. That's 3. So we're left with 33. is 1 minus negative 2 to the n. Never, never multiply those. Careful, you've got an exponent. Remember that bed's math. Some teachers teach bed math. Brackets, exponents, then division, multiplication. You always deal with exponent, but you don't know what n is, so you can't really deal with this. Okay, so what do we know? I'm going to do something sneaky here. Firstly, I'm going to bring that across and make it 32 is negative 2 to the n. Now, take this expression to the left. So the negative, whatever that is, becomes negative 2 to the n. And you left with negative 32 on the right. Okay, now, careful. Logs is not really going to help you here, but you probably agree with me. If you want the base as negative 2, that must be 5, because negative 2 to the 5 is minus 32. Please watch out for this thing. Okay, if the base is a positive, the logs will work, but not in this case. So exponents are still very, very important. Okay, so we've got that. So n equals 5. 5 terms will add up to negative 32. Do you believe me? Let's check it. Okay, what have we got? 3 minus 6 plus 12. Okay, what are we doing? We're multiplying by negative 2, so that's negative 24. Negative 24 times negative 2 is positive 48. Check that. 3 minus 6, negative 3 plus 12 minus 24 plus 48 will give you then your 33. Okay, so be careful with this. Watch out for that. These are classical exam questions that quite possibly could be asked. Okay, I'm covering all the angles for you guys, going fairly quickly, so at any stage that you're stuck, pause this DVD, go back and master it, and attack the worksheet that I've given you, and most of all, realize that one or two of these will definitely come up.